do physics paper 2, which is of theory paper, and it's going to be a specimen paper for 2023. And let's move to the question number 1, and this question is about graph. Figure 1.1 is the speed time graph for a stone as it falls to the ground. On the figure 1.1, mark a letter X to indicate a point where the rock is moving with a constant speed, and a letter Y to indicate point where the rock is decelerating. So in this question, what you are going to do is you are going to mark a point where the object is moving with a constant speed. So obviously you must have studied earlier that in a straight line the speed of the object is constant, and deceleration or decelerating or retardation is the point where your acceleration is decreasing when the object is basically decrease speed is or velocity is decreasing. And at time t equals to 0, acceleration of the stone is equal to the acceleration of free fall. Give the name of the force accelerating the stone at time equals to 0. So at this point the force which is acting on the object is going to be the weight of the object. The weight of the stone is 4 Newton. As it falls, the force F of air resistance acting on the rock changes. State the value of F at the time equals to 0. So obviously it will be 0 newtons. Don't forget the units, so it's already there. No force will be acting at that time. State the value of at a value of F at time equals to 10 seconds. So when it's 10 seconds, so you need to this is the point basically, and you need to find out the force acting on this point. So it's going to be the 4 Newton. Same force is going to be acting on that object. So there will be same force acting on that object because of the constant speed, because there will be no resultant force at that time. So the same amount of force will be acting on that. There will be no resultant force, no net force. Suggest why F changes between t equals to 0 and t equals to 10. So what they are asking, why the forces are changing or at this point. So as the stone falls, as the stone falls, it accelerates, or you can say that its speed is going to be increased, and air resistance will also increase. So whenever the speed is increasing, so obviously the amount of air resistance is going to be also increased on the stone. Okay, let's go to the next question. Use And the next question states that using figure 1.1, determine the acceleration of the rock at time equals to 4. State the unit of your answer, and you will need to draw a tangent in the graph. Figure 1.1 show you working. Okay, so what you are going to do is basically, if this is your graph and the graph is like this, so now you are going to draw a tangent at t equals to 4. Let's suppose this is your 4. So this is going to be your tangent drawn on that curve, and the coordinate for these are going to be 0 and 10, 0 and 10, and you can take any triangle. It's up to you. Either you can take a big triangle, so find out the coordinates at this point or this point, and I have taken this point, and I'm going to take another point that is going to be this one, which is around 6 and 42. So this is going to be, if you apply the formula of the gradient, so it's going to be 42 0 and 10 and 6 and 42. So this is going to be 42 minus 10 divided by 6 is going to be 32 over 6, which is equals to 5.33 meter per second square. So this is going to be your answer. Okay, the mass of the stone is 408 grams. Determine the force of air resistance acting on the rock at time t equals to 4. Show your working. Okay, first of all, you have to convert this number into kilograms. So obviously, force is equals to mass time acceleration. So mass is going to be 408 divided by 1000. Basically, we are converting it into kilograms, and the acceleration is given is over here, so this is going to be 5.33. So when you can solve this, so you will be ending up with 2.2 newton. Figure 2.1 shows a black car going up a hill on a sunny day, straight one way, in which the car is gaining thermal energy. So first of all, it's going to be the black color, which is a good absorber. Black color is gaining the thermal energy. Then it can be burning of fuel. It can be the friction, and the black color is basically the radiation from sun. So it's a one mark question. You guys can write any of these points. One way in which the car is losing thermal energy. So car is losing thermal energy by the process of radiation, because black color has absorbed the heat. So now it's going to radiate the heat. So it's going to radiate heat, and then it's going to be radiate the heat, losing heat by convection. And then it's the exhaust fans, exhaust, or the radiator thing, that is basically losing the thermal energy which is gained during the running of a car. Okay, moving to the next question. The car accelerates up the hill. In addition to increase in thermal energy, there are other energy transfer taking place. Describe how the other energy transfers. So how the other energies are transferred in this. So first of all, the fuel, which is chemical energy, is consumed up. So it's going to be decreased. Then it's moving up. So obviously the gravitational potential energy is increasing. So it's moving. So again, the kinetic energy is also increasing at that point. At one point in the motion, the kinetic energy of the car is 90 kilojoules. The mass of the car is 800. Calculate the speed. So we know the formula for kinetic energy is going to be 1 by 2 mv square. The kinetic energy is 90 kilo. So it's going to be times 1000, because this is a prefixes which is kilo, and it is going to be equal to 10 to the power 3, or you multiply with 1000. 1 over 2 mass is 800, and we need to find out this. So if you do the calculation over here, so you will be ending up with velocity equals to 15 meter per second. A passenger in an aircraft seals some air inside a plastic bag. Explain how the particles of air in the bag exert a pressure on inside of the bag. So first of all, the particles are moving. Particles are in random motion. This is the first thing that you are going to write. Particles, or you can write particles of air are moving randomly in the bag. Then there will be what? Collision. Collision will be increased. Then it's going to be, they are going to exert force on the wall. Force exerted on the wall of bag container, and then it's going to be the pressure which is going to be increased. When the bag is closed, the pressure of the air inside the aircraft is 80 kilopascal, and the bag contains 500 centimeter cube of air. When the aircraft is on the ground, the pressure of air inside the aircraft is 100 kilopascal. Calculate the volume of air inside the bag when aircraft is on the ground. So simple, we are going to use the Boyle's law formula over here, and we will plug the values over here. It's going to be 80. I'm not using k because it's going to be cancelled out, times 500 equals to, this is 100 times v2. So this is 80 times 500 divided by 100. So it's going to be 400 centimeter cube. State one assumption that you made in your calculation. So I made this assumption that no particles are allowed to escape, or you can say keeping the temperature constant, keeping the temperature constant. The point plotted on the graph in figure 3.1 shows the initial pressure and volume of air inside the bag. Sketch a line on figure 3.2 to show how the volume of air changes as the pressure increases. So we have to find out the data from the previous question. So it's going to be like if I take this volume and this is going to be pressure, because you see the graph is like volume and it's a pressure graph. So in the previous question, when the volume was 500 centimeter cube, the pressure was 80 kilopascal, and when the okay, kilo is already written over there, so I'll write only 80. And when the pressure was 400 centimeter cube, so the pressure was 100 kilopascal. So we have to draw the points. It's 80 and 400. This is already done, and 400 and 100 and 400. This is going to be your point. So now you have to draw the curve. So it's going to be like you have to use a clutch pencil to draw these curves. So it's going to be like this. Basically it's a volume and pressure graph. Volume is inversely proportional to pressure, keeping the temperature constant. So you have to draw this curve smoothly. Moving to the next question. One type of renewable energy source is shown in figure 4.1. Earth's surface cold water is going to be pumped down and hot water steam is going to be coming up. State the name of renewable energy source shown in figure 4.1, and that is geothermal energy. Geothermal energy. 100 kg of 1000 kg of cold water at a temperature 20 degrees Celsius is pumped down to the hot rock. The water returns partly as steam and partly as hot water. The steam and the hot water are both at temperature of 100 degrees Celsius. The specific heat capacity of water is this. Calculate the energy required to heat 1000 kg of water from 20 degrees Celsius to 100 degrees Celsius. So we know the formula for specific heat capacity is going to be mc delta theta or delta T. So over here we need to find out the energy. So mass is 1000. Then you are going to multiply with the amount of 4200. The specific heat capacity and change in temperature is going to be 100 minus 20, which is 80. So you will be ending up 3.36 into 10 to the power 8 joules. This is the amount of energy you need to do this. Okay, explain why more energy is transferred when 1 kg of steam cools to 20 degrees Celsius than whether when 1 kg of hot water cools to 20 degrees Celsius. You should include a reference to the arrangement of particles in the liquid and in the gases in your answer. So this is important because when you are answering this question, so you have to write it down in reference to the arrangement of the particles. So obviously what will happen, first of all, the steam is going to be condensed. Steam is going to condense. Then the temperature of the steam temperature will decrease to 20 degrees Celsius, and it is going to be converted into liquid. And latent heat is going to be given out. Heat is given out. Then you can also write the molecules, they are going to come closer. Molecules will come closer to each other. Kinetic energy is going to be decreased and intermolecular bonds are formed. So basically this is a 3-marker question, so you guys can write it down, and the potential energy is going to be decreased. So you guys can write any of these 3 points. Moving ahead, and this is another question. Figure 5.1 shows light and air incident on the side of a rectangular glass block at an angle of 60 degrees. The refractive index of glass is this. The light travels in a glass and incident on xy. Underline all the terms that describe the light wave. So light is an electromagnetic wave. It does not require any medium to travel. It is a transverse wave. At the point where the light enters the glass, the angle of refraction you need to find out. So it's written, the formula for refractive index is sine I over sine R. So over here we need to find out sine R. So it's going to be R equals to sine inverse sine I over n. You just plug the values inside it and it's going to be sine inverse sine 60 divided by 1.6. So you are going to be ending up with 32.8 degrees. So two significant figures is going to be 33 degrees. So the incident angle is 60, that you must know. Calculate the critical angle C of the light traveling in the block. So now the critical angle formula is 1 over n, or you can write it down n. Okay, we need to find out the critical angle. So what we are going to do is C equals to sine inverse of 1 over 1.6 is going to be again 38.7, which is around 39 degrees. At P, the angle theta between the ray and the normal is given by theta equals to 90 minus r. State and explain what happens to the light when it is incident on the side xy. So when you put your angle of refraction at this in this formula, so it's going to be 57, and the angle of incidence is going to be greater than the critical angle. So obviously there will be total internal reflection in this scenario. Okay, a 4.5 battery is connected in circuit with an ammeter, a light dependent resistor, and a 18 ohm fixed resistor. Figure 6.1 circuit diagram is the circuit diagram. The light incident on the LDR causes the resistance to be 9000. Calculate the total resistance. So it's a simple question. It's 1 over 1800 plus 1 over 9000. So if you add it up, so it's going to be 1500 ohms. Reading on the ammeter. So we know this Ohm's law. The reading on the ammeter measures the current, so voltage divided by resistance. So voltage is 4.5 and resistance is what, 1500. So the current is 0.03 ampere, or 3 into 10 to the power minus 3 amps. A very bright lamp is switched on and the intensity of the light incident on the LDR increases. State and explain what happens to the current in LDR. So what will happen to the current is going to increase, and the explanation will be the function of LDR is this, that whenever there is an increase in the brightness, so resistance will decrease and the amount of current is going to increase. State and explain what happens to the current in the 1800 ohm resistor. So in this case, this is first of all a fixed resistor, and this is what, parallel to the battery. So it will the amount of current will be remain same in this case, and the voltage and resistance, they are going to be dropped across fixed resistor and resistor, and it's going to be constant. Figure 7.1 shows horizontal current carrying wire PQ in the gap between the poles of a permanent magnet. There is a magnetic field in the gap between the north pole and the south pole. The current in the PQ is from left to right. Describe the effect of magnetic field on the PQ. So it's going to be like describe the effect of magnetic field on the PQ. Okay, so if you apply Fleming's left hand rule, so it's going to be out of the page. PQ will be out of the page. So it's again, either you can write or memorize father, mother, child. You can write this or memorize this mnemonic. Father is the force, mother is the magnetic field. Don't change the directions. First, always remember this. Thumb will be your force. You cannot change your index finger to force. Your index finger will be your magnetic field, and your middle finger will be your current. So if you apply this rule, so it's going to be out of the page. State the effect of PQ on increasing the strength of magnetic field in the gap. So what will happen? PQ will experience more force. Obviously, when you increase the strength, so it's going to be more force, and it will or faster quickly or faster, PQ will move out of the page. Figure 7.2 shows part of a torch. The torch does not contain a battery. The torch is shaken, and this causes the magnet to move backward and forward through the coil. Explain why an electromagnetic force EMF is induced across the coil when the magnet moves. So what is going to be like, why its electromotive force has been induced? So it's basically due to magnetic field or due to magnetic flux, or you can write it down, change in magnetic field or again flux. State one way to increase the EMF induced, is going to you increase the number of turns, use a stronger magnet, or you guys can do one more thing, move the magnet faster. So by doing these, move the magnet faster, the EMF will be increased. So you guys have to memorize these three modes. As the magnet moves into the coil, the induced EMF produces a current in the coil. Explain how this opposes the motion of the magnet. So it's going to be produces the magnetic field, obviously the magnetic field, and then north pole will be created at right hand of coil, and then there is going to be repulsion. Figure 8.1 shows a circuit containing 230-volt AC supply connected to a television and two lamps. In normal operations, both switches are closed. The power supply to each lamp is 40 watts and the power supply to the television is 120 watts. Calculate in normal operation the total number of kilowatts hour of energy supplied in the circuit for 1 hour. So total power will be, you add them, 120 plus 40 plus 40, so you will end up at 200 watts. Now if you want to find out energy, so basically what you need to do is power times, so this is 1 hour, and energy is P times, okay, I'll write down the formula as well. Power is 200 watts divided by 1000 because we are converting it into kilowatt hour, and time is 1. Okay, so it's going to be like 0.2 kilowatt hour. The current in each lamp. So again, you have power, you have current. So this is like P over V. P is your 40 each lamp, because one has 40 watts, so it's going to be 230, and it's going to be 0.174, which is 0.17 ampere. Explain why the switches are placed in the live wires and not in the neutral wire. So one reason is isolation, or isolate the appliances from high voltage or current. Otherwise what will happen? Electric shock. Otherwise electric shock, or it can be dangerous when switched are off. Moving to the next. State one advantage of connecting two lamps in parallel in this circuit. So if one fails, other will work. Figure 9.1 shows the main part of a nuclear reactor. The fuel rod contains uranium 235, which can undergo nuclear fission. Describe the process of nuclear fission and that occurs in the fuel rod. Your description should include the role of neutrons in this process. So pay attention while you are attempting a question, and how you are going to solve this question is like this. Neutrons are bombarded on radioactive element or atom, like for example in this case it's going to be uranium. So neutrons hit radioactive element, they will split up into two smaller daughter radioactive nuclei. In this process, neutrons are given out, including huge amount of energy. So you can also write it down that these are the neutrons plus radioactive elements. So it's going to be daughter radioactive element 1, daughter radioactive element 2, plus neutrons and plus energy, huge amount of energy. So you can label them as well neutrons. Explain what happens as control rod is moved out of the reactor core. So what will happen, there is going to be a chain reaction. It's going to be unstoppable. It's going to be like a lot of energy will be start generating. The fusion process will be increased, a lot of splitting up of the radioactive elements, and it's going to be a dangerous one if it's not controllable properly. The nuclear reactor releases energy at a steady rate. By referring to the neutrons, describe what is happening to achieve this steady rate. So neutrons are absorbed by control rods to keep it steady. Explain the purpose of the moderator in the nuclear reactor. So basically they slow down the neutrons, and there will be a greater chance of being absorbed by radioactive element. The sun is a star in a stable part of its life cycle. Using idea about forces, explain how the sun remains stable in the part of its life cycle. So what happens is this, basically it collapses due to gravity, and there are balanced forces. Basically they are balanced by outwards forces due to high temperature or pressure. This is what happens. Describe what's happened to star of similar mass to the sun at the end of the stable part of their life cycle. So basically they ran out of hydrogen, and they become red giant, and they shrink, or you can say cool down, to become white dwarf. And when a star starts to run out of hydrogen, basically that is the fuel for the nuclear fusion, it becomes unstable, and there is a less energy being produced by the nuclear fusion to sustain the outward thermal pressure, and the core collapses inward under the gravitational potential energy. It is being converted into kinetic energy, and the core becomes hot, and there will be the fast burning of the remaining fuels, which causes the expansion and the cooling of the surface gases, and stars turns into red giants. Okay, the next question, it is going to be like the orbital speed of the earth around the sun is 30 kilometers per second. Use the value of the to calculate the distance of Earth from the Sun. Show you working, state the units, and this is what we need to do. So speed is going to be 30 kilometers per second. Orbital speed is equals to 2 pi r over t. So we need to find out the value of the calculate the distance of the Earth. Okay, so now we are going to do this thing. V times t over 2 pi, which is going to be r. So velocity is what? 30 times time is 365 into 24 hours into 3600. This is basically we are converting into seconds. So this is going to be 1.5 into 10 to the power 8, and the distance is measured in uh, uh, meters. Okay, so I want to add more thing in this case, a scenario like in this case I basically I want to add in this case is that there is a stable star and it turns into red giant, and there is low mass star, and there are basically I'm drawing the life cycle of stars, and it turns into nebula, or you can say white dwarf. DWA. And then it's going to be white dwarf at center. So after cooling it's going to be white dwarf, and then a black dwarf. Over here when there is going to be supernova, and then it's going to be either a neutron star or it's going to be a black hole. So this is the life cycle of a star. Moving to the next question, and it states that the light emitted by distant galaxies shows various amount of redshift. State the name of the galaxy that contains our sun. So it's going to be the Milky Way. State what is meant by the redshift and describe how it is caused. So whenever there is a redshift, so there will be increase in wavelength. There is going to be decrease in frequency and photon energy of electromagnetic electromagnetic radiation. So this is what happens in redshift. An astronomer compares the spectrum of the light emitted by the sun with the spectrum of the light emitted by the distant galaxy P and Q. Figure 10.1 shows the same four lines as observed in all three spectrums. So increasing wavelength, sun, galaxy P, galaxy Q. Okay, state the what figure enables the astronomer to deduce about the galaxy P and galaxy Q. Explain the astronomer's reason in your own answer. So what is happening? Q is faster than P because Q has larger redshift, and Q is further away from P because redshift increases with distance. Thank you very much.